back. Hey guys, it's Rishi once again, and today we're back with volume of prisms. So now in this video, we're going to show you how to work out the volume of a prism. But before we get to working out the volume though, it's important to answer a basic question. What actually is a prism? Well, a prism is a three-dimensional shape, just as the one that you're seeing here, which has the same two-dimensional shapes repeated along its length. And you can see we have the beginning, which is our circle here, and also at the end, which is then repeated. Likewise, we have our triangle in this section here, and we'll also have a triangle here. And then finally, for the third shape, we have our compound shape here, and we'll also have our compound shape here. So take a look at these examples here, and all of these shapes, as you notice, are your prisms. Notice how they have the same two-dimensional shapes that I've just drawn, all from a cylinder, a triangular prism, and finally your compound shape. You might even see various different formulas for working out the volume of different prisms, but they all follow the same rule. And that again is the area of the cross-section times by the length. So you can see the area of the cross-section for the circle, for the triangle, and for the L shape, and then they're all multiplied by the length. Remember now, the cross-section is the two-dimensional shape repeated throughout the prism's length. So you simply work out the area of this cross-sectional shape using your knowledge on areas, and then multiply that area by the length, which is also sometimes referred to as the depth. And check out the examples that I'm going to be going through just to help build your understanding. So just like other videos, feel free to pause the video to attempt the question or even make notes. Just as we went through our previous video of surface areas, you should now have a basic understanding. But for those who do not worry, we are going to go through this from the very beginning. So before I actually start with this, I'm going to start off with a quick example here. So let's simply draw out a cuboid. Okay, marvelous. So now that we've gone ahead and done that, let's give it some measurements. So we've got 3 centimeters by 8 centimeters and by 10. So let's start by working out the volume of this cuboid. Now this is a type of prism with a rectangle repeated throughout the shape's length. So here's how you should approach the question and set out your working. So area of cross-section times by the length. And that again is going to be the area and the rectangle times by the length. So again, if we take a look at this, we are going to have so again, to calculate this, let's have our base times our height, which gives us 24. And then 24 times by our depth, which is 240 centimeters cubed. And that is the volume, because volume is measured in cubic. So again, I hope that example was clear. Let's now take another example here. And let's go for a triangular prism. Perfect. Let's give our height as 4 centimeters, our base as 6 centimeters, and then our depth as 9 centimeters. Wonderful. So again, this type of prism has a triangle as the cross-section. So we're going to work out the area of the triangle first and then multiply that by your depth or length. So again, as you know, with our volume of our prism, it's going to be the area of this cross-section here multiplied our length. So let's now go ahead, choose a different color. And we now need to work out the area of this triangle. So again, if we have an area of a triangle, we're going to have our base times height divided by 2, which we then know is 4 times 6 divided by 2, which gives us 12 centimeters squared. That is our area done. We are then going to take 12 and multiply it with our length, which is 9, and that would give us 108 centimeters cubed as our volume. And that's as simple as it gets. So I hope you can see how we've gone ahead and we've started off with the volume of a cube, the volume of our cuboid, and then with a triangular prism. I hope that was clear. Let's now move over into our set of questions here. Okay, let's start with question number 1. So now in this question, this shows us a prism, and we now need to work out the volume of the prism. So again, let's go with our area of cross-section CS. So again, what am I going to do? I'm going to split this shape up into 2. I know the top is 2 centimeters, so this section here will also be 2 centimeters. So if I'm working out this section here, we know it's 2 multiplied by 1, which gives us 2. And then I'll have my 2 at the top multiplied by 3, and that will give me 6. So in total, my cross section is going to be 8 centimeters squared. And now what do I need to do? I need to go ahead and multiply this with our length, which is our 12 centimeters. So to get our volume, let's have 8 times 12, which gives us 96 centimeters cubed. And there we are. So I hope that question was clear. Again, your 2-step method is find the area of the cross section, and then to calculate the volume, which is 8, which is the total, multiplied by 12, which is your length. Marvelous. Let's go for question number 2. So now we're based with a triangular prism. So once again, step 1 is area of cross section, and step 2 is to calculate our volume. So let's start with our cross section here. We know it's a triangle, so we're going to be working with our base times height divided by 2, which is 3 times 4 divided by 2, which is 6 centimeters squared. We are then going to take our 6 centimeters and we're going to multiply this by our length, which is 8. And that there will give us 48 centimeters cubed. And that's all we need to do. And we've now got 3 marks in the bag. Beautiful. Okay, question number 3. And here we are, our trapezium. But I'm going to take the same method as I did before. Area of your cross section, and then the volume. So let's start with our area of cross section. Now with our formula here, we would have half with a plus b multiplied by our height, where a is 4 and 8 is b. So let's go ahead and substitute this into our formula. Okay, so we know 4 plus 8 is 12, divided by 2 gives us 6, and then if we times it by 7, that is 42 centimeters squared. So that's our area of our cross section, and then we take our 42 and multiply it by our length, which gives me 420 centimeters cubed. And there we are. That's 3 marks in the bag. So I hope you guys are getting a clear understanding of how to calculate this. Let's now jump into question 4, and I'm going to pause here. I want you guys to attempt this, so feel free to pause the video now, and then we'll go through it. Marvelous. Okay, let's go through this. So again, let's go step 1, area of cross section. Now in this particular question, you can see we've got x here, but it doesn't matter. We're simply going to have our base times height divided by 2, which is going to be 4 multiplied by x divided by 2, which again can be simplified as 4x over 2, which will then give us 2x. Because 4 divided by 2 is 2, and that x comes with us. So now we have 2x is our area of cross section. I'm going to simply multiply 2x by our length, which is 9, and that will give me 18x. But remember here, they've given us the volume. So now we know that 18x equals 198. So how do we make x the subject? Well, the first thing we're going to do is we're going to divide both sides by 18. So we have x equals 198 divided by 18. Now, for those who are finding this slightly challenging without a calculator, let's write this out in a fraction form. And you can see that they are both even numbers. So if we divide both sides by 2, we will get 99 divided by 9. And for those who know their times tables, we know that 9 goes into 99 11 times. So our answer will be 11. So now we know that the value of x is 11. And we can take this one step further by checking this as well. So if we replace x with 11 and we use our formula on the left-hand side, let's go for 11 times by 4 divided by 2, which we know is 44 divided by 2, and that gives us 22. If we then take our 22 and we multiply this by 9, which is our length, that then gives us 198. And there we are. Beautiful. So again, that's just a way to check if your answer is correct. Okay, let's move over to question number 5. So again, the diagram shows a cuboid, and it's a square with an area of 25 centimeters squared. And we know our C to G is 12 centimeters. So work out the volume. Well, again, they've helped us out. This is our cross section here, and we have our length of 12. So in order to work out our volume, we simply need to have 12 times 25, which gives us 300, and that's centimeters cubed. So remember, 2 marks there. Identify your area, which is your cross section, multiply it by your length, and you're good to go. Let's go for question 6. So Bob has a van, and he's using the van to deliver boxes. And each box is a cuboid measuring 60 by 30 by 40 centimeters. And the van has a space for the boxes in the shape of a cuboid with these specific lengths. Again, before I attempt anything, I'm always going to make sure that my metric unit is the same. So as I'm working with a 40 by 60 by 30 centimeters, I'm going to convert my length, width, and height to centimeters. So again, that's your 300 centimeters, that's 180, and that's 200. Now we've gone ahead and done that. Let's go ahead and divide each length by the length of the box, each width by the width of the box. So length, width, and our height. So again, we know our length is 300, we know our width is 180, and our height is 200. And now we're going to divide this by the length, the width, and the height of the box. So our length is 60, our width is 30, and our height is 40. And that gives us 5, 6, and 5. So now we know that this is the dimensions of how many boxes we can fit. So the total will be 5 times 6 times 5, which gives us 150. So now we know that the van has space for 150 boxes. And there we are. So again, what did I do? I made the units the same before then dividing to see how many boxes can fit as per the length, the width, and the height, before then calculating the total area here. Okay, question number 7. You're doing really well coming this far, so keep up the great work. So we have a cuboid, and we also have the volume. So step 2 is done for us. We now need to calculate the value of x. So we're going to work backwards here. So let's now work out step 1, which is your cross section, which is again 4 times 12 times by x. So again, we know that will equal 48x. So if you go for step 2, our volume would be 48x, which is equal to 120. We are then going to work out the value of x. So we know we need to divide both sides by 48. So let's do this in a fraction here. We'll have x equals 120 over 48. We'll half both sides, so we're to 60 and 24. We'll continue to do it, 30 to 12. And then we have 15 to 6. So now with 15 to 6, we can even simplify that further as they're both divisible by 3, and that would give us 5/2. And 5 divided by 2 gives us 2.5. So we now know the value of x is 2.5 centimeters. And there we are. And that's just another way that you can take if you don't want to use a calculator. Or simply you can use the bus stop method and do 120 divided by 48. Okay, let's go to question 8. And don't forget now, at this stage, you should be much more confident with questions relating to volumes of a prism. So feel free to pause the video, attempt the question, and then go through the solutions. All right. So the diagram shows an empty water container, and Fiona is going to use a bucket to fill the container. And each bucket can hold 12 liters of water. So how many buckets of water will be needed to fill this container? Remember now, this is a real life example here. So once again, let's start off with the area of our cross section. So let's go with 90 by 40, and that's just this cross section here. And we know that's 3,600 centimeters squared. And then step 2, to calculate our volume, I'm going to then multiply that by my depth, or length you can say, by 50, and that will then give us 180,000 centimeters cubed. Remember now, in terms of conversions, 1 liter is equal to 1,000 centimeters cubed. So we know in terms of our volume, if we divide 180,000 by 1,000, that's going to give us 180 liters. So we now know our volume is 180 liters. But then each bucket holds 12 liters. So this is where we need to go ahead and divide 180 by 12. Again, we can go ahead and half this to 90 over 6, and then 45 over 3, which will give us 15. So in total, we can fill 15 buckets of water to fill that container. Okay, question number 9. We are almost there, guys, so keep up the great work. And don't worry if it's overwhelming. In the beginning, it will take you time, and repetition is key. So don't give up, otherwise if it was this easy, everybody would do it. Okay, question number 9. Here is a cube, and work out the volume of 5 of these cubes. So the first thing I'm going to do is work out my volume of 1. So 3 cubed gives us 27 centimeters cubed. And then I'm going to take this 27 and times it by 5, and that will give me 135, and that's my answer there. Short and simple question. Let's move over to question 10. So now a diagram shows an empty water container, and the container is going to be filled using a house pipe. And the water will flow into the container at a rate of 2 liters per second. So how long will it take us for the entire container to be filled? So again, I'm going to go ahead and start off with my volume here, which is going to be 120 multiplied by 70 multiplied by 50. Again, now remember that's a combination of my cross section and my length. We know that gives me 420,000 centimeters cubed. And we know that 1,000 centimeter cubed is equivalent to 1 liter. So again, if I divide 1,000 by 420,000, that will give me 420 liters. I now have that. I know it's going to flow at a rate of 2 liters per second. So I'm going to have 420 divided by 2, which gives me 210 seconds. So what that shows is that in 210 seconds, this entire container will be filled. Okay, question number 11. So we have a total surface area of a cube, which is 150 centimeters squared. And they want us to work out the volume of this cube. Now we know it has 6 faces. So if we have 150 and divide it by 6, that gives us 25 centimeters squared. And that's going to be for each face. And I'll just write over here that we have 6 faces. So now, as 25 is a square number, we can simply square root 25, which will give us 5 centimeters. So we now know that each length and width is going to be 5 centimeters. So we can simply go ahead and calculate the volume by doing 5 cubed, which would then give us 125 centimeters squared. And that is our answer. So I hope you can see how I've worked inversely to calculate this question. Beautiful. Let's go for question 12. So now the diagram shows a water container, and the container is 2/3 full with water. The water is going to be used to fill cups, and each cup holds 175 milliliters of water. So how many cups of water can be completely filled with water from the container? Well, let's take a look here. So the first thing I'm going to do is combine step 1 and step 2 to calculate the volume, which again is going to be the area of the cross section, 15 times by 14, and then multiplied by my length, which is 12. That then will give us 2,520 centimeters cubed. Now I've gone ahead and calculated that. The next stage is to work out what 2/3 is of that entire volume. So if you guys have watched my fractions of an amount video, this is where this will become useful, where you simply divide by the denominator and then you times by the numerator. So having done that, we know 2,520 divided by 3 gives me 840. I then times that by 2, which gives me 1,680. So that means our answer is 1,680 milliliters. So the container is filled up with 1,680 milliliters. So now we know that each cup will hold 175 milliliters of water. So if 175 milliliters equals 1 cup, then 10 cups is going to be 1,750 milliliters. And we know that we only have 1,680, so it has to be less than 10 cups. So now if we go ahead and aim for 9 cups, we'll have 1,750 take away 175, and that will give us 1,575 milliliters. So overall, we know that 9 cups of water can be completely filled with the water from the container. And that's 9 cups. Again, I hope you can see how I'm working through these questions, breaking them down into smaller, more manageable steps. Again, there can be other methods that you can follow, but again, I won't dive through every single method here. I hope this was clear, and let's now move over to the final question. So now we have a triangular prism, and the diagram shows the cross-section of the prism being a right-angled triangle. So let's calculate the volume of the prism. So again, we don't have our height here. So I'm going to label this as x. And so what I'm going to introduce in this question is Pythagoras theorem. And now with Pythagoras theorem, we would have a squared plus b squared equals c squared, with c squared being your longest side. But fortunately, we have our longest side. We just don't have one of the shorter sides. So if we write this out as x squared plus 12 squared equals 13 squared, we now need to make x the subject. And by doing so, this plus 12 will become a minus 12 squared. And so we'll be left with x equals 13 squared minus 12 squared. And if we calculate that, that will be x equals 169 minus 144, which will then give us 25. Remember now, at all stages, x was a squared, but we want to find out the value of x. So the inverse of x is square root. So now if we calculate the square root of 25, that gives us 5. So we now know that x equals 5. So now we've done that, let's go ahead and work through our two-step method, with our step 1 being our cross section. We know it's a triangle, so we'll go with base times height divided by 2, which is going to be 5 times 12 divided by 2, giving us 30 centimeters squared. Step 2, we'll work out our volume, which is going to be 30 multiplied our length of 8 centimeters. And that there gives us 240 centimeters squared. So we now know that the volume of this prism is going to be 240 centimeters squared. So I know you've learned something new here today with our Pythagoras theorem. This is a topic that we will be covering. So once again, please do make sure that you are subscribed to our channel. But this does bring us to the end of our session. So I hope you now feel much more confident in terms of volumes of a prism. But please do remember, as we mentioned in the beginning of the video, that no matter what shape or type of prism you are working with, they will all be the same. The area of the cross section multiplied by the length. So keep up the great work, and I'll see you in the next video.